Today I am going to make the video on crystal field splitting in square planar complexes. Now before going to discuss the crystal field splitting in square planar complexes, in the previous class or in the previous video I have clearly explained that how the crystal field splitting happens in the square planar complex. So the gist of the previous video is the crystal field splitting in square planar complexes is derived from crystal field splitting in octahedral complex via tetragonal structure. And in the part 1 of this video, I have clearly explained that among the EG two orbitals, in fact, dx square minus y square occupies the highest energy level, whereas dz square occupies the lowest energy level. And among the three T2G orbitals, dxy occupies the highest energy level, whereas the energy associated with the two dyz and dxz is one and same. They occupy the same energy level. So if there is any ambiguity, so please do watch the part 1 of crystal field splitting in square planar complex. Right, now based upon the basics which I have explained to you, let us see how the crystal field splitting happens in the square planar complex. Crystal field splitting in square planar complex. So initially, how will be the d orbitals? Initially, they will be in the degenerated state. 2, 3, 4, 5 d orbitals. Out of 5 d orbitals, one is dxy, next is dyz, dxz, dx square minus y square, and dz square. So before approaching of the ligand, that is before approaching of the ligand means before approaching of the electrons on the ligand towards the electrons on the metal, the degeneracy of these 5d orbitals is one and same. That is, they are associated with the same energy level, same energy. Now once the ligand starts to approach, in fact once the electrons on the ligand starts to approach the electrons on the metal, the degeneracy of these 5d orbitals is removed or being eliminated, by which these 5d orbitals occupies the average energy level. 1, 2, 3, 4, 5. dxy, dyz, dxz, dx square minus y square, and dz square. So the degeneracy has been removed when the electrons on the ligand starts to approach the electrons of the metal, and due to the repulsion the degeneracy is eliminated. Now already I have explained clearly that crystal field splitting in the square planar complex happens or is derived from octahedral complex, right? It is derived from octahedral complex. Now how the crystal field splitting happens in the octahedral complex? That is, EG set of d orbitals occupies the highest energy level, whereas the T2G set of d orbitals occupies the lowest energy level, right? So in order to get rid of the confusion, please do watch the crystal field splitting in the octahedral complex, which have made in one of the video, right? Now what happens? The EG set of d orbitals occupies the highest energy level, which is dx square minus y square and dz square, whereas EG set of d orbitals, 1, 2 and 3, T2G set of d orbitals, whereas the T2G set of d orbitals occupies the lowest energy level, which are dxy, dyz and dxz. So up to here it is crystal field, that is crystal field splitting in the octahedral complex, right? Till here it is the splitting in octahedral complex. Right. Now, already I have explained in the previous video clearly that among the EG set of d orbitals, the dx square y minus y square occupies the highest energy level, whereas the dz square orbital will occupy the lowest energy level, because in the case of square planar complex, how the ligands are approaching? The ligands are approaching along the x and the y axis. Now whatever the d orbitals in which the lobes are placed along the x and y axis will experience the maximum repulsion. And what are the d orbitals in which the electrons are sitting along the x and y axis? That is, what are the d orbital? What is that d orbital in which the concentration of the electrons along the x and y axis more? That is dx square minus y square. And in the case of square planar complex, the ligands are approaching along the x and y axis. So whatever the d orbital in which the electrons are sitting along the x and y axis are very much influenced by the repulsions, and as the repulsions is directly proportional to energy, it will occupy the highest energy level. So it will occupy the highest energy level, that is dx square minus y square will occupy the highest energy level, whereas dz square occupies the lowest energy level. Till here I have clearly explained to you in the previous video. And whereas in the case of the T2G set of d orbitals, the dxy will occupy the highest energy level, whereas the dyz and dxz occupies the lowest energy level, because in the case of square planar complex, the ligands are approaching along the x and the y axis. Now whatever the d orbitals in which the electrons are sitting along the x and y axis is experiencing the maximum repulsion, and that is the reason the dx square minus y square has occupied the highest energy level. Now, the dxy, how the dxy d orbital is formed? The dxy d orbitals is formed by placing the lobes in between the x and y axis. What does it mean? The electrons are sitting in between the x and y axis. Direct influence is not there. The direct influence of the electrons on the ligand and the electrons of the metal along the x and y axis is not there, but in between the x and y axis is there. So that is the reason the dxy d orbital among the three T2G set of d orbitals occupies the highest energy level. So dxy occupies the highest energy level, whereas the remaining two, the dyz and dxz, dyz and dxz occupies the same energy level, because in this x is there and in this y is there, right? So in order to get rid of the confusion, please do watch the previous video. Please do watch the previous video. Right. Now, so initially what is happening, to summarize? Initially the d orbitals are in the degenerate state whenever the metal is not in the contact with the ligand. Once the ligand started to approach the metal, that is in fact whenever the electrons are starting to move towards the electrons on the metal, then the degeneracy is being eliminated, by which these are occupying the average energy level. Now the splitting is occurring, or splitting is taking place as in the case of octahedral complex, and this is how the octahedral complex splitting is. That is, each set of d orbitals occupies the highest energy level, whereas the T2G set of d orbitals occupies the lowest energy level. So up to here it is octahedral splitting. Up to here it is octahedral splitting. Now as the electrons and the ligands are approaching the electrons of the metal along the x and y axis, the dx square minus y square is experiencing the maximum repulsion, because of which it is occupying the highest energy level, whereas the dz square is occupying the lowest energy level. And among the T2G, that is three T2G set of d orbitals, the dxy influence the maximum repulsion, because the ligand electrons are approaching the metal electrons along the x and y axis. So whatever the d orbitals in which the electrons are placed in between the x and y axis will experience the maximum repulsion. Accordingly, the dxy is occupying the highest energy level, whereas the dyz and dxz are occupying the lowest energy level. So up to here it is tetragonal. It is tetragonal splitting or tetragonal structure, we can say that. Tetragonal splitting or tetragonal structure. Tetragonal structure or tetragonal splitting. So because I already said that crystal field splitting in square planar complex is derived from octahedral splitting via tetragonal structure, via tetragonal splitting. Now further what happens? Now as the ligands are approaching along the x and y axis, now the dx square minus y square will experience the maximum repulsion and occupies the highest, very highest energy level. Very highest energy level. Right? And what is that next d orbital which occupies the energy level next to the highest energetic d orbital? That is dxy. Because the ligand is approaching along the x and y axis, and in the case of dxy, the electrons are placed in between the x and y axis. That is the reason the next d orbital which occupies its position with respect to the d orbital dx square minus y square is dxy. dxy. So dxy. 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 Right. Now, as already clearly explained, that in the dz square, the back lobe of some portion of the dz square is in between the x and y plane. Is in between the x and y plane. Since it is in between the x and y plane, it experiences the maximum repulsion after dxy d orbital. So it occupies the next level, right? It occupies the next level. It occupies the next level. Right? Now finally, this dyz and dxz, as they are not influenced by the electrons on the ligand, they occupies the lowest energy level. They occupies the lowest energy level. So this is how crystal field splitting happens in the square planar complexes. Right? Up to here I have explained again. So in the case of a tetragonal structure, what is happening? Dx square minus y square is occupying the highest energy level, and dz square is occupying the lowest energy level, which are the EG set of d orbitals. In the T2G set of d orbitals, dxy is occupying the highest energy level, whereas the dyz and dxz are occupying the lowest energy level. But in the case of sphere planar complex, what is happening? The electrons on the ligand are approaching along the x and y axis. Since the electrons on the ligand are approaching along the x and y axis, whatever the d orbital in which electrons are sitting in between, or electrons are sitting along the x and y axis, will experience the maximum repulsion. And as the repulsion is directly proportional to energy, it will occupy the highest energy level. And what is that? D orbital among all the 5 d orbitals in which the electrons are sitting along the x and y axis. That is dx square minus y square. So that is the reason it is occupying the highest energy level. Now the question is, what is that d orbital among the 4, right? Among the 4. So fifth one is over. Among the 4 is occupying the next energy level. That is dxy. Because the electrons on the ligand are approaching along the x and y axis. In the case of dxy, the electrons are placed, or electrons are located in between the x and the y axis. That is the reason the dxy among the 4 which are left will occupy the next energy level. Now coming to the next one. 3 are left. Out of the 3, which occupies the next level with respect to dxy? That is dz square, because the back lobe of the dz square, d orbital, is in between the x and y axis. So the electrons on the ligand impact will be there on the dz square d orbital. Not exactly, directly it is not influenced, because some portion of the dz square is in between the x and y axis. So direct influence is not there, but more influence is there when compared to the dyz and dxz d orbital. So that is the reason dz square occupies the next energy level with respect to dxy. Now coming to the last, in the case of dyz, y is there, and in the case of dxz, x is there. Now the last orbitals which occupies their level are dyz and dxz, and both are degenerate d orbitals, because in the case of dyz, the approach of the ligand is there along the y-axis. In the case of dxz, the approach of the ligand is there along the x-axis. That is the reason the dyz and dxz in the case of square planar splitting are degenerate d orbitals. That is, the energy associated with dyz and dxz is 1IC. I hope you understood the video. So please do comment, because if you comment only, I will come to know whether it is understandable to you or not. So please do comment. Thanks for watching this video.